Well, hello, Kent here with another video. This time with something a little bit different. This evening I want to talk about running my camper AC and heat, refrigerator, microwave, lights, television off of generator power and battery power. I recently purchased a device, and I'll put the description of the device in the um, description below this video. And here on the screen. But the device allows you to basically rewire some of the controls of the AC compressor, and there's some pretty sophisticated electronics in the device that allow the compressor to do for lack of another word, a slow start. It's not just a start capacitor that kicks the compressor on when the compressor is a little bit aged and slow to start. This is not just a start capacitor. It's a pretty sophisticated electronic package that monitors the current and somehow manages to allow you to use a 2,000 watt generator on a camper AC unit that before you would never be able to do that. It would kick the compressor out right away. In fact, I've tried it. I tried starting the AC or the heat on the camper with a 2,000 watt generator. Never ever could get the compressor to fire. It would always stall, trip the breaker, shut the compressor off, or whatever. And I discovered this unit that allows you to modify the unit. The hardest part of this project is removing the heat pump from the camper. Uh, and other than that, wiring it up was pretty simple. And my son and I pulled the unit out of the camper and modified it with their instructions, very simple instructions. Installed the unit, put everything back together. I have a 2,000 watt generator, fired it up, plugged my camper into it, turned the air conditioning on, and it fired right up and ran for, I don't know, a couple of hours without any trouble whatsoever. Ran the refrigerator and the compressor simultaneously. Of course, the microwave is about 1,000 watt in itself, so you try to crank, you're running the AC and the refrigerator together. It's probably around 1,800 watts. And then, of course, you turn the microwave on and you shut it all down, obviously. So you got to do the math. You got to figure out what you need to run. But in our case, we just wanted to be able to take the camper and run up to the local park and pop it open real quick and turn on the AC, let it cool, go out and do a walk around the park a little bit, come back, and then go into the camper and have a little picnic with the dog. And the weather has been so hot, it's just really hard to enjoy being outdoors in parks, and just, it's just too hot to enjoy. So taking the camper up to the Blue Ridge Parkway here in North Carolina, we would just pull off to an overlook, pop the camper up, and then we didn't have the AC, and so it was just really miserable sitting inside the camper having a little picnic. I mean, I've got this nice camper and I want to use it, so this was our solution. And I'm telling you what, we went to a local park, Scott Dam in Wilkesboro, North Carolina. It's about 45 minutes from here. I had the little 2,000 watt generator. It's got super quiet generator. It's made by Generac. There are a lot of them available. And I plugged that baby into the camper and started it right up, turned the AC on, and we hung out there for an hour and a half or so, just reading, surfing the net. The dog was with us. We had our lunch in the camper, and we're just in the parking lot of the park. So I mean, you have to know where to go, where you have permission to just pop up your A-frame camper. And if someone had said you can't camp here, well, we're not really camping, and it would take me 1 minute to shut everything back down and move on. But the idea is to be able to get out on a day trip and not suffer, either freeze to death because there's no heat, or pass out from the heat when you don't have any AC. So I want to show you I'm not going to bother with the generator. There are 1,000 videos out there for running your generator using this device. So my purposes to this evening are to show you some of the connections that I made to hook up to a 2,000 watt inverter and run the AC unit and the refrigerator off of this setup. So I'm going to just kind of jump right in the middle of it, but I wanted to say this at first. Initially I had 2 batteries, both of them individually connected to the 2,000 watt inverter. And then I had my camper plugged into the inverter. And what I discovered, and I'm using 4 AWG battery cables, so it's about the size of my index finger, copper braided, really good stuff. I got it off the Amazon, and I'm running an 18-inch cable from one battery to a black and a white to the inverter, and then I've got a 12-inch cable from the other battery to the inverter. So I'm basically paralleling 2 12-volt batteries into the inverter to get me 12 volts, and both of those batteries are run about 650 CCA. I think one is 130 continuous, the other 160 continuous, so it's got plenty of power. And when you parallel, you double the current capacity of your setup. So I knew I'd have probably a couple of hours of capacity if I wanted to run it that long. And I used the heavy duty cable so that I didn't lose a lot of stuff in heat through the wire. Long story short, I had to fiddle with the configuration of how the batteries were connected to the inverter in order to get the compressor to start. And once I got the cables connected, I think I have one battery that's running, that's 5 years old, so it's reached its end of its life. And my guess is that when I hook that battery directly up to the inverter, along with the other battery directly up to the inverter, that the inrush current, when the compressor tries to start, there's probably a poor cell somewhere in that battery, and it drags down. The voltage will drop significantly, and the inverter just can't handle it, so it won't start the compressor. So I thought, well, I know this thing ought to run. So after I got the batteries connected correctly, the compressor started every time, not a problem whatsoever. You'll see in the video that the batteries are supplying about 115 to 120 DC amps. And so that would give me roughly, if I'm using both batteries and they were both in good shape, I should be able to get about, since they're about 160 continuous, I should get an hour and a half, basically an hour and a half of runtime without any trouble at all before the voltage drops too low to where you start creating problems for the lead acid batteries. So I let it run for, I'm thinking the test ran for 35 minutes, and there was no end in sight. Compressor ran the whole time, and I turned the AC temperature down real low to let it run. The fridge was running, the lights were on. I think I even had the TV turned on, which is no power whatsoever. And there might have been a little small box fan running in there. So I had it pretty well loaded up. I think I ended up calculating that with 115 DC amps coming off of the battery at 12 volts, and I checked that, it was about 1,400 watts, 13 and some change, that I was delivering. So the inverter was perfectly comfortable. It wasn't warming up at all. The fan running, and the fan was running, and you could barely feel any heat coming out of the inverter. So it was managing it very well. My whole point is that if I'll install those batteries in that camper, put the inverter in there, and wire things up correctly with a bypass switch between battery power and line power, I can take that camper anywhere and run what I need to run. If I need the microwave, I'll shut the AC off for a minute, run the microwave, do my thing, and then start the AC back up. So I'm sorry to go on and on here, but I really wanted you to know that guys are doing this. They've been told you can't do it, you can't do it. Don't buy a small generator. You waste your money. You have to get a big generator. I did not want to buy a 100-pound generator. For one thing, I don't have anywhere to store it on the camper. And I don't want to hang 100 pounds off the back bumper. It's not designed for that. But I will put a 45-pound generator off the back bumper if I need to. Or at least I can carry 45 watts, set it inside the door, close everything up, and I'm good to go. So take a look at some of these wiring experiments to give you a feel for what I was doing, and hope it helps inspire you to try some things with your own setup. Okay, I've got 113 DC amps running, and air conditioner is running. Look at the way I have it hooked up. I've got two 4 AWG leads running to the same battery. I had it hooked up to separate batteries, hooked up here, and it refused to start the compressor. It would not start. I tried it 3 times and it would not start the compressor. The amperage would go up and then come right back down, and it wouldn't start. So I took both of these and hooked them to one battery, and then I jumped the 2 batteries together with these wires, and it started. And I'm running around 114 amps, and it's continuing to climb as the voltage drops on the battery. And I don't have any idea what the voltage is just yet. Here's the thing. Let me disconnect one of these. I'm going to disconnect this lead right here that jumps these 2 batteries together, and let's watch what happens to the current. All right, increase slightly up to 117 amps. I hook it back up, drops to 115. The only thing I can figure is that this battery has a bad cell in it, and so when the high current demand hits it, it just drops out, and it pulls this one down too, or it drops out enough to compensate for this one. So with both leads hooked up to this battery, most of the current is coming out of this battery. We can look at this. Let's just see. Okay, I'm pulling 38 amps out of that battery, and and let me just hook it here. Let me yeah, and 115. So if I unhook this one battery, all the power, if I unhook this battery completely, all the power is coming out of this battery, and it's delivering 118 amps. So this old battery is not doing anything for me. In fact, it's creating a problem for me. It's only producing 38 amps, or 40 amps. Okay, there you see. Out of the 100 and whatever I said I had, 130 or 116. Okay. Here's another thing I wanted you to see. This is a long wire, this is a short wire, and when I mean long wire, it's maybe 18 inches, and this one's a foot. So watch the current reading on the 1 foot wire. That's 1 foot wire is 67 amps, and the 18-inch wire is 46 amps. And we'll check the black ones just to make sure. There's the short wire, 69 amps, and the long wire 44 amps. Can you explain that? Can you explain that? So if I've got 160 amps reserve, I'm assuming that means continuous duty until the voltage drops below a reasonable level. That means I've got a little over an hour. You could do the math. Probably an hour and a half would be an accurate statement. These leads are nice and cool. They're not warm at all. So that 4 AWG times 2 here is really doing the job. So we don't have a heat buildup. Connectors are not warm. Connectors aren't warm. So give me some feedback. Well, I just noticed something, Jesse. Look, it's a 5-year-old battery. So, you know, what do you expect, right? 5-year-old battery. That explains why that battery's so bad. And if you take this times 12 volts, you get about 1400 watts. So this system is delivering 1400 watts. The inverter is cool as a cucumber, not even blowing hot air out the back. So it's doing really well. I think this setup, if I put another battery in the trailer side by side and had a great big disconnect switch or a bypass switch between line current and battery current, and rig this up somehow to all that work. I could do short runs with this when we go picnicking. Could just use battery power to run the AC or heat, and then on longer extended trips we could put the generator in and run the generator for 11 hours or whatever it is. So once I switched these cables around, the compressor started right up. It surged up to like 130 amps, and then it settled in at, and I don't know whether that's a reliable number because you know how these meters work, but and it settled in at about 115 amps. So just thought you'd like to know how all this worked out with this new 4 AWG wire. And like I said, it's just as cool as it can be. Just a ever so slight. This one is ever so slight because it's drawing 69 and this one's drawing 30. One more thing. 120 amps total, and the little battery is drawing 47 amps. So delivering 47 amps out of 120 basically. So what are we talking about? 75 amps. 75 and 50. So 75 amps delivering and 50 amps delivering for a total of 125 or whatever. So I don't know whether that has anything to do with the capacity of the battery. This actually is a 550 CCA, and this one is a 750 CCA. So and a reserve capacity of 140 and a reserve capacity of 160. So those numbers probably mean something, and that might explain why this one's producing less current. Obviously one's bigger than the other, so it would make sense. Okay, I've been running 20 minutes, solid 22 minutes I've been running on the compressor. Got the trailer door open and cooling off Yadkin County. That cool air ought to be reaching you shortly. Yeah, it's hot. So it's still cranking away here. I'm going to go ahead and end the test. I don't want this battery to, I don't want to wipe out this battery, and you're supposed to recharge them when they get to about 11 volts, so I better just stop the test before I don't want to cause any damage to this expensive marine battery. So there you go.